Welcome, everyone. If you're in a business mathematics course, I'm willing to bet you've asked yourself, probably late at night staring at a textbook, when am I ever going to use this? It's the classic question, right? Well, today we're not just going to answer that question. We're going to answer it so powerfully that you'll see exactly how the abstract ideas in calculus connect directly to the huge, high-stakes decisions being made in the boardroom every single day. So let's dive in. So let's start with a very real problem. Imagine a company launches a fantastic new product. Now, the cost to make that very first unit is going to be different from the cost to make the 1,000th one, right? You get more efficient. And the money you make, the revenue from that first sale to a super excited early adopter, that might be way higher than the revenue from the 1,000th sale after competitors have shown up. Everything is constantly changing. So how does that CEO at the end of the quarter get a real, solid, precise number for the total profit? A simple spreadsheet that just averages everything out? No way. That's not going to cut it. You need a tool that's actually built to handle continuous change.
And that tool, that secret weapon, is the integral. I want you to stop thinking of the integral as just some weird symbol in your math book. Think of it as a powerful summation machine. Seriously, it's designed for one specific job: to take a function that is constantly in flux, a rate of change, and to calculate the precise total accumulation over any period you want. It is, and I mean this literally, the mathematical language that describes how modern business actually works.
Okay, this slide really gets to the heart of it. Look at the difference here. On the left, you've got your standard spreadsheet. It gives you a static snapshot. It's like a single photograph of your bank account on the last day of the month. It tells you what happened. But look at the right. That's the integral. That's not a photo. It's the full movie. It shows you the dynamic story, every single twist and turn in revenue and cost day by day. It doesn't just tell you what happened, it shows you how and why it happened. And let me tell you, real business strategy, that lives in the how and the why, not just the what. All right, so to make this all feel real, let's get our hands dirty. We're going to build a case study from the ground up. Let's pretend we're consultants for a brand new tech startup, and our very first job is to get a handle on their production costs. This, as you know, is the absolute foundation of any solid business model. So the key idea we need to master here is marginal cost. Now, in calculus speak, marginal cost is simply the derivative of the total cost function. But in business speak, it's way more intuitive. It's the exact cost of making the very next product off the assembly line. It is not the average cost. It's the instantaneous cost at a specific moment. And why does it change? Well, think about it. The cost to make your 10th widget might be pretty high, but by the time you're making your 500th, you've figured things out, you're buying materials in bulk, that specific unit actually costs less to make. It's that rate of change that we need to capture. Okay, so let's say our startup's data nerds have come up with this function for us. Now, let's break this down piece by piece. First, see that little apostrophe, the C prime? That's your calculus clue. It screams, hey, I'm a derivative, I'm a rate of change. The 50 part suggests that the cost to produce that very first unit, when Q is basically 0, is about $50. But the minus 0.02 Q part, that's where the story is. It tells us that for every extra unit Q we make, the cost to make the next one goes down just a little bit. This is a beautiful, simple model of those efficiencies of scale we were just talking about. So here it is. This is the central challenge for this section. We don't have a simple, flat price per unit. We have this dynamic, living function that tells us the cost at any single point. So how in the world do we use this rate of change to find the total accumulated cost for that whole production run of the first 1,000 units? Well, by now you've probably guessed it. The solution, the only way to do this accurately, is to integrate. What we're really doing is summing up all of those tiny individual marginal costs for every single unit, from unit number 0 all the way up to unit number 1,000. That integral symbol, you can think of it as a giant S for sum. We're taking the integral of our marginal cost function with respect to the quantity, dq, and we're doing it over the interval from 0 to 1,000. This process is going to give us the precise total variable cost. And when we run the numbers and perform that integration, we get $40,000. Now, this is a precise number. It's not a ballpark, it's not an estimate. It perfectly accounts for the fact that the first unit cost about $50 to make, while that 1,000th unit cost quite a bit less. What would that be? 50 minus 0.02 times 1,000? Just $30. The integral has perfectly added up the costs of all 1,000 of those units, each with its own slightly different price tag. That, right there, is the power of this tool. Fantastic. We've totally nailed the cost side of things, so now let's apply the exact same logic to the other side of the accounting ledger, revenue. What's cool here is that the process is a perfect mirror image, which should really help this whole concept click into place for you. So, Just like we had marginal cost, we have marginal revenue. You guessed it, it's the derivative of the total revenue function. It represents the extra cash you bring in from selling just one more unit. And just like cost, this number is almost never constant in the real world. Think about it. The first few people who buy your product might pay a premium price, but to sell more, you might need to run a sale or lower the price. So the revenue from that 1,000th unit you sell could be a lot less than what you got for the first one.
Okay, so our startup's marketing team hands us this function. Again, R prime of Q tells us the marginal revenue. That 100 suggests that the very first unit we sell brings in about $100. Nice. But that minus 0.04 Q term, that's the reality check. It shows that as the quantity Q we sell goes up, the additional revenue we get from each new sale goes down. Maybe that's because the market is getting saturated, or because we're trying to attract customers who are a little more price sensitive.
And here's our parallel question. We've got the rate of change of revenue. What we need is the total revenue we've accumulated from selling all 1,000 of those units. How do we find it? Come on, you know the answer by now, right? We integrate. So we set up our definite integral of the marginal revenue function. Again, from 0 to 1,000. We find the antiderivative, plug in our bounds, and voila. The result is $80,000. This is the exact total revenue. It captures the full story of their sales, from that first premium customer all the way to the 1,000th. Okay, we now have the two critical pieces of our puzzle. All right, this brings us to the grand finale, the moment of synthesis, the real aha moment. We've painstakingly calculated total cost and total revenue using the exact same powerful method. And now we can finally put them together to answer that CEO's big question from the very beginning. And this slide just lays it out so perfectly, doesn't it? On one side, you have the total pile of money that came in, $80,000 in revenue. On the other side, the total pile of money that went out, $40,000 in costs. The visual just makes the next step feel completely obvious. So the bottom line is, profit is just revenue minus cost. Total profit is total revenue minus total cost. It's that simple. Now, from a calculus perspective, we could also get here by first creating a marginal profit function, which would just be marginal revenue minus marginal cost, and then integrating that. You'd get the exact same answer. Either way, the fundamental business logic holds true. And the final answer is $40,000. $80,000 in revenue minus $40,000 in costs gives us a total profit of $40,000 for the first 1,000 units. We have now answered that CEO's question, not with a guess, but with mathematical certainty. We've given them a number that is defensible, precise, and tells the true financial story of their new product. Okay, now this all seems pretty straightforward when we lay it out step by step, but I know from experience that there are some common traps that students fall into. So let's switch gears a bit, put on our workshop hats, and talk about how to do this right every time and avoid those simple mistakes that can lead to totally wrong answers and, really bad business decisions. Let's walk through this checklist. Number 1, and this is a big one, you must always start with the marginal function, the derivative, the rate of change. You can't integrate a total cost function and expect to get anything meaningful. Number 2, just burn this relationship into your brain. You integrate a rate to get a total, always. Number 3, that little constant of integration, the plus C. For definite integrals like the ones we did, it cancels out, so no big deal. But if you were finding the general total cost function, that C would represent your fixed costs, things like rent and salaries, which are absolutely critical to the real business picture. And finally, number 4, be so careful with your interval. If you integrate from 1 to 1,000, you just missed the cost of the very first unit. That's an error. Your interval has to match the exact question you're trying to answer. This might be the most important part of our entire conversation, because crunching the numbers is only half the job. The real value comes from using those numbers and the functions that created them to make smarter, better, strategic decisions. Let's stop being just mathematicians for a second and start being business strategists. I want you to imagine you're in a board meeting and your boss turns to you and says this. Let's translate it from math speak to business speak. The integral of marginal profit is positive. Okay, easy. That means we made money. We're in the black. Great. But its second derivative is negative. What does that mean? Well, if the first derivative is the rate of change, the second derivative is the rate of change of the rate of change. It tells us about the shape of the curve. A negative second derivative means our profit is still going up, but it's growing at a slowing rate. The growth curve is starting to flatten out. This is a massive early warning sign that a strategist needs to see.
So as a strategist, that one piece of mathematical insight immediately sets off a bunch of critical questions. You'd say to your team, okay, guys, the math is telling us we're hitting a point of diminishing returns. Our growth is slowing down. So what's our move? Is it time to change our pricing? Maybe we should launch a huge new marketing campaign to find a different type of customer? Or is it time to go back to the drawing board and actually innovate the product itself to boost our marginal revenue? Do you see how the calculus directly feeds the strategic conversation? It gives you a precise language to describe exactly what's happening in the business.
And that brings us to the end. I really want to leave you with this question to chew on. Today, we've talked about cost, revenue, and profit. But business is just packed with things that are constantly changing. Think about the total lifetime value of a customer whose spending habits evolve over the years, or the total carbon footprint of a factory whose emissions change depending on production levels, or even the total market share of a new app over its life cycle. All of these are complex, dynamic problems that you can understand, model, and solve with the incredible tool we've explored today, the integral. So please, don't just learn this for the test. Learn it as a new way of thinking. I promise you, it will serve you well, no matter where your career takes you.